Welcome to this ESS revision video on topic 4.4 and water pollution. So before we do this, you need to understand that water pollution is the contamination of bodies of water by pollutants either directly or indirectly. And water pollution is a serious matter globally because it kills 14,000 people a day because we all rely so much on water. Nearly 500 million people, however, around the world still don't have access to clean drinking water. But water pollution isn't just about poorer parts of the world. It affects both developed countries, less developed countries, higher economic countries, less economic countries. Why is water so important? Because of our bodies, and therefore it is critical for it to be healthy, for us to be healthy as a result. So there are different types of water pollution. These water pollutions can be anthropocentric or natural, so we can produce them, but water can also be polluted by natural sources. For example, animals will naturally produce waste in the wild that will go into the water as well. It can be a point source that can come from a precise location, or it can be more diffuse and come from lots of different places, called a non-point source. It could be organic waste going in, so manure for example, or it could be inorganic waste such as chemicals from a factory. It can be direct, so it can directly affect organisms, or it can react with other chemicals in the river to make new products which will often affect the ecosystem. Freshwater pollution sources are often agricultural, sewage, industrial or domestic releases, whereas marine often focuses on pipelines going into the sea, atmosphere or human activities at sea, such as oil development, for example, leading to discharges. So there are lots of different types of water pollution that I thought would be worth you just sort of seeing. This isn't in the specification so much, but I think it's quite useful for you to just sort of see. So we've got diseases which could go into the water, such as bacteria and viruses. Cholera in humans was a massive disease. It still is in parts of the world where water isn't treated. Waste that removes oxygen from the water, sort of sewage and manure, will often take the oxygen out, killing the fish. Inorganic chemicals such as acids and metals from industry, organic chemicals, oil is classed as an organic chemical, pesticides, detergents, fertilizers cause eutrophication, sediment from where there's been trees chopped down which causes erosion, which causes sediment to enter the water, that can cause a problem, and radiation from power stations, for example, as a result. So we can measure water pollution in one of two ways. The first way is using a biochemical oxygen demand, which is basically measuring accurately the amount of dissolved oxygen required to break down the organic matter in a given volume of water. So if water is polluted, it might have a lot of organic matter, and basically using oxygen breaks it down because microbes will break it down. So if you've got really polluted water, you may need a lot of oxygen to break down the pollutants. If you've got little oxygen needed, it's a clean water. You can also use biological indicator species. So this is generally invertebrates in fresh water, and they will live in like cleaner water areas to less cleaner water areas, and we can identify which species live where, which tells us how clean. And environmental biological indicators are often an early sign of change in the ecosystem because they are the most sensitive organisms. So invertebrates are freshwater, they're sensitive to oxygen concentrations. So the stonefly nymph would need high oxygen because it lives in low pollution areas. The tubifex worm will live in very low oxygen levels because it can cope with pollution. Therefore, if you see this change starting to happen, it's an early warning that oxygen levels are going down, and that is due to the bacteria that break down the sewage building up as the sewage builds up. High oxygen, remember, always means low levels of pollution. Low oxygen means high levels of pollution. The example you need to know in detail is eutrophication. And eutrophication is when we add additional nutrients to the stream or river, and that then causes a change in the aquatic system. Now, the potential sources of these nutrients you need to know. Most people remember sewage, most people remember fertilizers, but any of the others are also important. So detergents, for example, your washing machine could cause this to happen. Drainage from animal breeding systems and topsoil erosion could take nutrients into the water, and that could cause eutrophication to happen. So what is eutrophication? Well, when we add these chemicals in, so say from fertilizer or from pollution, these chemicals cause a series of events to happen. So the first thing that happens is you get an increase, particularly in nitrates and phosphorus. That causes a growth of algae, which will then block the sunlight in the top levels of the water. So your algae builds up here. Okay, that means that the sunlight then cannot get past the algae as a result. Therefore, the plants at the bottom will sort of die, and therefore those things will die, and bacteria will then also decompose those plants using the oxygen. So the bacteria uses the oxygen, which then leads to fish death as a result. Now, eutrophication has massive impacts, and here's an example in America. So water coming out of the rivers in Louisiana come in, bringing all these minerals into the Gulf of Mexico, and this causes a huge algal bloom, and as a result you have something called a dead zone because of a lack of oxygen, and you can see the size of this dead zone is absolutely massive. Now, this is caused because there is oxygen deficient water, therefore there's loss of biodiversity because nothing can survive there. The higher plants that need more light can't survive because they're blocked out. Aerobic organisms need oxygen, die, and as a result there's increased turbidity in the water. Now, you need to be familiar with management strategies across this whole course. So management strategies always split up into three areas. You have human activity, and we can look at how we can reduce the human activity. We can look at how we can reduce the pollution, and we can look at then the long-term effects. So the strategies is we could first of all alter the human activity. So that's the first bit that we need to do. So I'll get rid of that and do that again. Okay, so altering human activity. Now, how can we do this in water pollution? Well, we can use alternative technologies that don't add the pollution. We can adopt alternative lifestyles, so using less fertilizer, less pesticides. We can reduce, recycle, and reuse. We can then regulate reducing the pollution to reduce the levels, so we can set standards in countries, and we can do measurements as a result. And then once we've reduced this impact, you then need to look at cleaning up the pollution, and that means we need to go into places that have got eutrophication and remove the actual pollution, for example. And then when we've done that, replanting and restocking the biodiversity to make it as a healthier environment as it was. So the three stages you need to understand is we need to alter human activity, we need to regulate the pollution, and then we need to restore the habitat. New ESS course, there has been a push on the detail you need for this. So here you can see a little bit more detail which we need to focus on. So strategies for reducing pollution and eutrophication. Altering state one is always altering and reducing human activity that produces it. So we could look at banning or limiting the detergent with phosphates in it. We could use eco detergents with no phosphates in them, plant buffer zones between the fields and the watercourses, stop leaching of slurry and sewage into from their sources, and educate farmers about efficient timing for spraying fertilizers. To reduce the release of pollutants, we could treat wastewater more before removing the phosphates and nitrates. We could divert or treat sewage more effectively and minimize fertilizer doses on the land using organic matter such as manure instead. Once the pollution has been caused, how can we remove it and restore the environment? Well, we could pump air through the lakes. So if we can pump the air through the lakes, that will aerate it, give the oxygen, reduce the impacts of eutrophication. We can dredge the sediment with high nutrients from the rake. We can remove excess weeds physically by using herbicides, that's obviously another issue, and we can restock the ponds with appropriate plants and any organisms needed. Now, one area that you need to know for 2024 onwards as well is about plastic in the oceans. So plastic is obviously a big issue these days, and it affects water pollution. So there are lots and lots of different types of water pollution. They can be caused by disease, chemicals that shouldn't be in there, organic chemicals, plant fertilizers, sediments, radioactive substances, but also plastic. Plastic is a synthetic fiber or polymer made from petrol. It's widely useful, and that's why it's being used all across the world, but we know it's non-biodegradable. So it doesn't break down by bacteria, and it will persist in the environment. But when we say break down in bacteria, we mean break it down into its original products. It does get smaller though and break down into smaller bits of plastic called microplastics, which we may not be able to see clearly, but they are non-biodegradable and then can accumulate in organisms and cause health problems. So if you look at where the plastic comes from in the oceans, you can see how wide a spread problem it is. Cigarette butts cause a huge amount of issues. Plastic bottles, plastic bottle caps, wrappers, straws, glass bottles, and takeout containers. So all these things cause issues in the ocean. Now, in terms of how long they last, because they're non-biodegradable, you can see here that the time they take to last can be up to 600 years if they slowly break down in the oceans. And that's not really taken into account when they become microplastics. It's just the actual substance itself no longer being recognizable. So microplastics are also non-biodegradable. They can cause bioaccumulation, and they can magnify along the food chains, causing biomagnification. We do not yet really know how they cause harm to human health and whether they will be harmful to us or not, but the likelihood is they will be. The plastics basically start on the land to cause this. It then travels along the rivers. It'll end up in the oceans, and then the plastic is slowly mechanically broken down by the waves, and they become microplastics, which we believe will exist indefinitely in the oceans unless we can get them out somehow. So the microplastics that we found basically come from a couple of sources. If it's a microplastic, we say its diameter is less than 5 millimeters in width, whereas nanoplastics are less than 100 micrometers in width, so that's 0.1 millimeter. Now, these are the sources of those, so a lot of it comes from clothing articles like that, car tires, but even dust has microplastics in it. That settles on the ocean surface and sinks into the oceans. Microplastics are small, as we said, and they used to be very common in skincare products and cosmetics because they were good facial scrubs, etc. They've now been banned internationally, but obviously that has a historic trace where they were entering the water stream.